Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry, for you to teach here today one shot in solutions and colligative properties. Are you ready? So please confirm, am I audible and you can see my video? That's good. Dear children, warm welcome to the session. Here I can see so many students online. Today we are going to discuss about solutions and colligative properties, and this particular topic carries definitely 1 mark in IIT NEET examination. Definitely you will be getting a question and you can grab 4 marks from this. Hi Wajid Mir, how are you? Welcome to the session. Welcome to the session, right? So before going for the session into the details, I can say, Aish Yadav, hello. I can say today's class I can guarantee you that all the subtopics that are there in the solutions and colligative properties will be going to be discussed, and also I can assure you that today we will be discussing this in one shot and you will be confident enough to solve all the questions, and beech mein questions bhi hai na. Yeah, please explain. And before going for this type topic, I just want to give you Madhushri, hello. I just want to give you what Infinity Learn is doing for the students preparing for NEET examinations. I can show you 4 students as an example. Ashrita, Ahmedyuti, Akhil Verma and Satyanarayan. Takes only 2 to 3 minutes. Just be patient. And Ashrita got 2023 310 marks and 2024 661 marks. You can see 2023 versus 2024 marks. The score is compared exactly, it is more than a double. So how it is possible? These students are following our lectures like you, and है topic पढ़ता है, हाँ साफ topic भी पढ़ाता है. Okay, so you can see 310 से 661 351 marks बढ़ गया marks, and Akhil Verma 313 marks से 658 तक पहुंच गया, so 345 marks बढ़ गया. And also you can see 310 to 652 marks Himadyuti, just like Ashrita, and 342 marks is increased. And Satyanarayan also got 310 330 in 2023 and 650 marks in 2024, and 320 marks is an increment. So how it is possible? And it is possible only by following the lectures and following the guidelines from the Infinity Learn, and you follow our lectures and ace your NEET examination preparation. For that we say, crack NEET examination and reserve your medical seat in premium medical colleges. So this is possible simply by attending the classes regularly in a regular session. We are periodically giving every day a topic. Here from JK, Ashish Yadav, this is Dr. Suresh, Faculty of Chemistry, for you. And like these sessions and attend the sessions on regular basis, like our sessions on YouTube platform, and share with your friends. इन लोगों के भी फायदा होना चाहिए, and for that you please subscribe to Infinity Learn NEET YouTube channel. You are from Kashmir, very good, nice. And also we have Infinity Learn app, where that Infinity Learn app you are going to see the live classes, mock test, and create your own test, and 24/7 doubt resolution. Whenever you have some not confident topic in any topic, okay, any subject, you can create your own test in that particular topic. Okay, that is called CYOT. It is there with Infinity Learn app. Okay, and I am from Hyderabad, Infinity Learn. Okay, Wajid Mir, you are from Jammu Kashmir, right? Welcome to the session. So let's go ahead with we are on social media. Okay, we are on social media like YouTube, Instagram, and Facebook and Telegram. Especially for Telegram channel, link is available in the description box. You can just click that link and you can go with this. And when you join in this Infinity Learn Telegram channel, you will be having a daily quizzes, and हर सेशन का शेड्यूल भी मिलेगा, सेशन नोट्स भी है, and assignments भी है, and many more are there, and you all follow in this YouTube platform and you can use the best. And link is there in the description box, and you can click it and join in the Telegram channel. So हर सेशन का schedules आपको मिलेगा. and two more slides are there. आजकल आर्टिफिशियल इंटेलिजेंस एआई हलचल ज़्यादा है, हर जगह पे चैट जीपीटी जैसे है. And a streamlined AI tool is introduced by academics, Infinity Learn. It is first time in India in academics, Infinity Learn is introduced your AI tool. By using AI tool, you are going to have goal settings, set your academic and skill enhancement goals, and also you will be having a live classes, live classes by eminent faculty, and also test paper analysis for the proper assessments. The test that you have given is assessed by AI tool, so that you will be having a personalized guidance where you are good and where you need to improve. And also you will be having a self study, learn, practice and revise. इसके लिए आपका concept based short videos and mock and practice test भी and flashcards for revision. And also you will be having 24/7 doubt resolution. कभी भी कोई भी कहीं भी doubt है, whenever you have a doubt, your doubt can be resolved a click away at any time. Okay, that is again driven by AI, artificial intelligence. In that you can see one more important thing, India's largest scholarship examination, that is score examination, that is provided by Infinity Learn. Link is there in the description box. Everybody please click onto the link and just enroll your score examination. Definitely मैं एक दिन कश्मीर आपको आके आपको मुलाकात करूँगा. Okay, definitely it's a long dream to visit Kashmir. Thank you for your invitation. Okay, so score examination, why it is a India सबसे बड़ा scholarship examination, क्योंकि ये scholarship का वजह से performance based आप बच्चे लोग का 1 करोड़ तक आपका स्कॉलरशिप वर्थ मिलेगा. ओके, एंड स्टडी सेटअप लैपटॉप भी है, एंड आपको कुछ पढ़ाई करना चाहते हो आपको ऑनलाइन क्लासेस भी है, आपको लैपटॉप दिया जाएगा, एंड आल्सो एजुकेशनल अलाउंसेस भी है, एंड अप टू 100% स्कॉलरशिप भी मिलेगा. एंड यू कैन सिट एट योर होम एंड यू कैन राइट दिस एग्जामिनेशन. इट इज कंप्लीटली ऑनलाइन, एंड also you can write this examination. You may be related to Infinity Learn or you may be studying in other schools or colleges, doesn't matter, फिर भी आप स्कोर एग्जाम लिखने को आप एलिजिबल है ना. So please look at that link, it is there in the pinned messages, and you can click this and join this Infinity Learn score examination. So far so many students are given this exam, you also make a compete with them, and this test is completely online. And last but not least, that is NEET 2025 All India Test Series Pack. And why this test series pack? अगर आप कुछ पढ़ाई करने के लिए, कुछ आप एग्जामिनेशन प्रिपेयर करने के लिए आप इतना मेहनत कर रहे हैं ना, ये मेहनत किस डायरेक्शन में जा रहे हैं, प्रॉपर असेसमेंट होना चाहिए. सो ये प्रॉपर असेसमेंट के लिए टेस्ट सीरीज पैक जरूरत है, क्योंकि उसमें आपका 27 ऑल इंडिया टेस्ट सीरीज है, 13 यूनिट टेस्ट, 4 पार्ट टेस्ट एंड 10 ग्रांड टेस्ट बेस्ड ऑन नीट पैटर्न बच्चों, एंड 20 ऑनलाइन नीट फुल सिलेबस मॉक टेस्ट भी तैयार है, 25 टॉपिक वाइज प्रीवियस ईयर क्वेश्चंस, एंड आल्सो 3 फिजिक्स केमिस्ट्री बुक्स विल बी गिवन टू यू, and every question that is there in the package will be given a video solution and detailed solutions and performance reports for every test. And also last but not least, that is your performance is checked, benchmarked with Sri Chaitanya students, so that you will be having a prediction of this is the score you may get and this is the rank you may get. So for that इतना सारे फैसिलिटीज़ आपको मिला था 5,999 तक, लेकिन 50% विंटर ऑफर दे रहे हैं इन्फिनिटी लैन 2,999 once you apply YouTube 50 of coupon code. Yes, link is there in the description box, just click it and you can get it, है ना. Definitely. So our promotion is over. Let us start with solutions and colligative properties. आप जो भी टॉपिक पढ़ाई कर रहे हैं ना, ये टॉपिक में क्या क्या सब टॉपिक होगा एंड क्या क्या सब टॉपिक का आपका इंपॉर्टेंस ज़्यादा है, मानना पड़ता है। इसका टाइप्स ऑफ सॉल्यूशंस है एंड मेथड्स ऑफ एक्सप्रेशन कॉन्सेंट्रेशंस है एंड वेपर प्रेशर, राउल्ट लॉ एंड कॉलिगेटिव प्रॉपर्टीज एंड एबनॉर्मल मॉलिक्यूलर मास, इसके वजह से वांट ऑफ फैक्टर। दीज आर द 7 मेजर टॉपिक्स एंड अमॉन्ग दिस 7 मेजर टॉपिक्स मैं आपको प्रॉमिस कर रहा हूं वांट ऑफ फैक्टर के हिसाब से पक्का आपका क्वेश्चन मिलना की संभावना है एंड राउल्ट लॉ एंड कॉलिगेटिव प्रॉपर्टीज, बस उसमें एबनॉर्मल मॉलिक्यूलर मास वांट ऑफ फैक्टर इस्तेमाल करके आप करेक्ट कर सकते हैं। बच्चों शुरू करेंगे आप टॉपिक्स फटाफट, एक शॉट में रिवीजन है। एक बार थम्स अप एंड फायर मुझे डालना शॉर्ट बॉक्स में ताकि आपका थोड़ा एनर्जी बढ़ने के लिए। बाजिद मिर, मधुश्री हेलो, आशीष यादव। So starting here, types of solutions. A solution is a component, is a mixture, homogeneous mixture of a solute and a solvent. A solute क्या होगा, a solvent क्या होगा? When you mix these two now, it should be homogeneous mixture. Uttam, are Thanos hand, where did you go yaar? In the last month also, you're not seen. Suresh Kumar, good afternoon. Yes, let's continue. So solute is the one which is present in the less number of moles and the solvent is the one which is present in the more number of moles. And based on the solutions, types of components in a solution, it is a binary solution, means उसमें एक solute एक solvent होगा। ternary solution इसमें एक solvent and दो solutes होगा। like that you have a ternary solutions and all. But as far as the syllabus is concerned, we have only binary solutions in our syllabus. Okay, so based on the physical state of the solutions are classified into 3 types, and solid solutions, liquid solutions and gas solutions. Okay, फटाफट जल्दी करने का कोशिश कर लेता हूँ। So let's talk about among the different types of solutions we have. Depending upon the physical state of the solvent, the solutions are can be gas or liquid or solid solutions। बेटा उसमें आता है gases, gas plus gas हमेशा homogeneous mixture होते हैं। air is an example। liquid dissolved in the gas, that is a chloroform when it is vaporized, and solid dissolved in the gas कैसे, आपका कर्पूर है ना, camphor, ये सब्लिमेटेड, जो भी सब्लिमेटेड सब्सटेंस होता है ये कैटेगरी के अंदर आता है, सॉलिड इन द गैस। आर यू गेटिंग और नॉट क्लियर? सुरेश, उत्तम, वेयर डिड यू गो, हाउ आर यू उत्तम? आपका पढ़ाई कैसे चल रहे हैं? जल्दी। बशीद मीर, बहुत खुश हो गया उत्तम को देखने के बाद। सुरेश कुमार एंड उत्तम वर माय प्रीवियस स्टूडेंट्स इन द यूट्यूब चैनल इटसेल्फ। They improvised their chemistry skills after attending the classes with me. है क्या ना? Yes, एक thumbs up, उत्तम। And liquid solutions, gas in liquid, liquid in liquid, solid in liquid. उसमें gas in liquid आता है, it is a carbon dioxide dissolved in the water। हमका जो carbonated soda bottle है ना, okay, cool drinks है। I am fine, thank you बेटा, thank you। And liquid is dissolved in liquid as ethanol is dissolved in the water is an example, solid is dissolved in liquid, sucrose is dissolved in water. These are the various kinds of examples. You can say solid solutions, उसमें gas can be dissolved in the solid। weird example है, gas कैसे dissolve करते हैं solid में? solution of hydrogen, a hydrogen gas is dissolved in a palladium, that is called occlusion, and liquid occlusion, this is called occlusion। okay, लिक्विड सॉलिड में डिसॉल्व कर सकते हैं कैसे? अमालगम, मर्क्यूरी इन सोडियम मेटल, एंड सॉलिड इन सॉलिड, एनी एलॉय इज एन एग्जांपल। ओके बेटा, सो आगे बढ़ना टाइप्स ऑफ सॉल्यूशन में, एक्वियस सॉल्यूशन, नॉन एक्वियस सॉल्यूशन। जिस सॉल्यूशन में वाटर इज अ सॉल्वेंट इज एक्वियस सॉल्यूशन, जिस सॉल्यूशन में अल्कोहल इज अ सॉल्वेंट इज कॉल्ड अल्कोहलिक सॉल्यूशन। A solution में ammonia is a solvent is called ammonical solution. They are called non-aqueous and aqueous solutions. And non-aqueous solutions has benzene, chloroform, ether, carbon tetrachloride जैसा है। So concentration terms, methods of expression, concentration terms. So here you can connect with the mole concept. 11th standard first chapter, and you can have the concentration terms like methods of the concentration of the solution can be expressed in terms of percentages, molarity, molality, normality, mole fraction, all these things will come. नवदीप शर्मा, yes it is an adsorption. Adsorption करने के बाद homogeneous होगा. Yes, exactly, it is called occlusion. It is seems like homogeneous, right? It is absolutely adsorption, atomic level में होता है. ठीक है बेटा? So concentration, weight percentages and mass percentages. The amount of substance present in 100 grams of solution is called as, the mass of substance present in 100 grams of solution is called as mass percentage. Children, everybody open in a pen and a paper, write all the formulas that are available on the board, right? Thank you very much. Keep asking doubts, keep asking doubts. Doubts are highly appreciated in the chat box, okay? You don't spam it, but you can use it. ठीक है बेटा? Right. So all the formulas that are available, make a note of it. While noting, one round of practice भी हो जाएगा आपको फायदा हो जाएगा. Okay. Weight percentage is equal to weight of the solute upon weight of the solution into 100. And volume percentage, weight volume percentage, this itself can tell you the formula. So the weight volume percentage is equal to weight of the solute upon volume of the solution into 100. And also volume percentage, and in that volume percentage it is going to be volume of the solute upon volume of the solution into 100. जैसे liquid solutions में ये method इस्तेमाल करना बहुत आसानी है. And also you have molarity. It is defined as the number of moles of solute present in a liter of solution. That is what you can say molarity. In this molarity, you can say molarity is equal to number of moles of solute upon volume in liters. When that volume is taken in milliliters, you can say weight molarity is equal to weight of the solute upon molecular weight into 1000 by V expressed in milliliters. So this formula we use hundreds of times in the entire chemistry. Hey Kena, Navadip, Uttam, Suresh, Bajit, writing these formulas whenever I am making a box, it's a formula, you all make a note of it. ठीक है? And getting into the details about molar solution of which gram of the mole solute present in a liter of solution. So 1 milliliter. So from here a molar solution means इसका molarity 1 molar होगा. Yeah. So आपको जैसे आता है क्वेश्चन में मोलार, सेमी मोलार, पेंटी मोलार, डेसी मोलार, ये टर्म इम्पॉर्टेंट. सेमी मोलार का मतलब मोलारिटी 0.5. Decimolar means 0.1 molar. So the question is given. So a decimolar solution of sodium hydroxide. ताकि क्वेश्चन बोल रहा है आपका जो सोडियम हाइड्रोक्साइड का कॉन्सेंट्रेशन 0.1 मोलार का है. नवदीप, okay, centimolar 0.01 and also millimolar is equal to 0.001 molar. So this is the various denominations that we need in molarity, molality and the normality भी है. And also say molarity of the solution, the mass of the solution you want to know. From the molarity you can directly get into this mass of the solution is equal to molarity into volume of the solution in the liters into gram molecular weight. Okay, from there you can calculate millimoles and moles. Okay, some useful relations. If number of millimoles of the solute is present in VML of the solution, that is going to be MV. Okay, and if it is a millimoles, that is going to be MV by 30. So these are the points very useful when you prepare for the NEET examination. So NEET examination दौड़ना पड़ता है. Examination लिखने के वक्त में आपका झंझाट इतना होता है. So you shouldn't take a chance to recall the things. It should be there on the fingertips. सीधा इस्तेमाल करो. So for you, I am making you these useful tricks and methods. You can do it. Number of moles of solute present in liter of the solution is mv, and if it is a milliliter, it is going to be 1000. And also dilution करने के लिए, this is what you say, m1 v1 is the initial molarity and volume, and m2 v2 is the final molarity in the final volume. If you add something into it, that is called dilution. Dilution करने का m1 v1 is equal to m2 v2. एंड आप डाइल्यूशन करने के लिए कितना पानी ऐड किया, कितना सॉल्वेंट ऐड किया उसमें, that is delta V. So delta V is equal to V2 minus V1. Okay, so volume of the water to be added to get the solution known by V2 minus V1, that is M1 V1 upon M2 minus V1. You can say V2 minus V1 is equal to M1 minus M2 upon of V1 M1. So these are the simple tricks that can help you to solve the questions in the simplest way. Sometimes the question will be asked to prepare a solution from this volume 100 ml of 0.1 molar HCl solution, say of 100 ml of 0.01 molar HCl solution prepare करने के लिए आप कितना पानी उसमें ऐड करना चाहिए, so that we have to calculate V2 minus V1. ख्याल में रखो, this is kind of tricky questions that we need to have. Hope you are understanding, everybody. And if you want, I can have 2 sessions for this as well. Okay, molarity, that we already have this formula, and weight volume percentages, and the relation between the weight volume percentage is given. This molarity is equal to 10 into weight volume percentage upon gram molecular mass. काफ़ी important. अगर density और specific specific gravity आपका दे देंगे तो you can say 10 into specific gravity and it is a density into upon gram molecular weight, you can use it. Yes, if it is when the weight percentage and the specific gravity or density is given, तभी आपका 10 into specific gravity weight percentage upon gram molecular weight. You can use this formula, and in the NCERT textbook also this kind of formulas are so important. Any doubt? So I think I am revising many things in a single shot, right? So quickly we can do it. And also from this mixture, when M1 V1 is the solution, M2 V2 is the another solution, when these two are mixed to get a mixture, so the molarity of the mixture is equal to M1 V1 plus M2 V2 upon V1 plus V2. Okay, Navdeep Sharma writing the formulas. Navdeep Sharma writing the formulas. Okay, right. So let's talk about normality. आपका जैसे molarity normality भी है. Normality is equal to number of gram equivalents upon number of gram equivalents present in a liter of solutions. So how do you calculate that? You can calculate the normality by taking weight upon gram equivalent weight into 1000 by V ml. And how to get a gram equivalent weight? Or simply take the molecular weight divided by n factor. What is n factor? Valency factor. From there you can see what is the valency factor. Some useful values, yeah, जैसे आपका I just want to say normality is equal to molarity into n factor. N factor that is acidic nature of the acids, number of H plus ions by one molecule of acid that is donated. For base, number of OH minus. For salt, N factor is given as the total charge on either cation or anion. And also you will be having a redox change. The N factor is going to be, say, now total change in the oxidant state per molecule of the reactant, oxidant or reductant. Okay. Normality, that is already we have taken. And yeah, for exact neutralization, when a titration is doing a reactant and another reactant in a titration experiment, at the end point you can say weight of a base upon gram equivalent weight of a base is equal to NaVa upon 1000. So normality of an acid and volume of an acid. Similarly, weight of an acid is also calculated. Understand? Write the formulas. Gautam, any doubts? Yes. So molality, it is the number of moles of solute present in 1 kg of solvent. Ah, very good. So number of moles of solute present in 1 kg of solvent. Just like the molarity, 1 liter of solution, in the molality it is a kg of solvent. As there is no volume parameter here, you will be having a simple thing here, and it is independent on the temperature, whereas molarity and normality depending on the temperature, right? So parts per million, just like a number of parts of the solute upon number of parts of the solution into 10 power 6. So per cent, that is into multiplied with 100, per million, that is multiplied with a million, that is 10 power 6. That is the simplest way you need to know. And also you will be having some useful relationship. Molality is equal to 10 into solubility upon gram molecular weight. Molality is equal to molarity into volume in weight of the solute in kg, and mole fraction of the solute is given m by 1000 into m plus 1000 by molecular weight of the solvent. So these are the simple methods you need to know. So the specific gravity ka matlab, here you can take a density. The relation between the density and the molality is given in the various factor. Everybody take a snap of this, take a picture, 3, 2, 1, click it, and also you will be having a mole fraction. It is the ratio of number of moles of one component to the total number of moles of the components in a solution is what you say the mole fraction. This mole fraction is also independent on the temperature. Okay, and also mole fraction of the component can be calculated. A is a component, B is a component, and the sum of the mole fraction of A and sum of the mole fraction of B is equal to 1. This helps a lot. And the solutions on the colligative properties, if required, I want to make it 2 sessions. Okay, we will discuss up to vapor pressure in this today's class, and colligative properties and want to have factor in the other class. Is that okay, Uttam? But अच्छा तरफ सीखना, आप जो भी सीख रहे हो ना, why this 1 shot or 2 shot question sessions are being conducted? बच्चों, आप अगर आप खुद ही पढ़ाई करना चाहता हो, सो एक चैप्टर का कम से कम करने के लिए आपको मिलेगा 3-4 दिन के लिए. And a senior faculty like me is teaching ना, you will be having a revision. 1 घंटे में हो जाएगा, 2 घंटे में, 1.5 घंटे में हो जाएगा. आपको फ़ायदा उठाओ, सो आपको फ़ायदा उठाने की कोशिश करो, and will conduct these sessions in a regular way. That's why we always say please attend the classes on the regular way, and please like our sessions, share with your friends, subscribe to Infinity Lane YouTube channel. Okay, let's talk about a question. Calculate the normality of 0.98 weight by volume H2SO4 solution. आप कैसे कैलकुलेट कर सकते हैं? Normality is equal to weight by volume. So weight of the substance by gram equivalent weight into 1000 by V in milliliter. So weight is 0.98 मान लो, 98 is the molecular weight, इसका n factor 2 है, 1000 by 100. So that आपका आएगा आंसर 3 का 0.2 का आ जाएगा. You are multiplying with 2. Understand? Any doubt? Clear? So like that we can keep on solving the questions. If possible, we'll solve it. Otherwise, we just revise the question. You want me to solve the questions or revise the concept? अगर रिवाइज करेंगे तो आधा कॉन्सेप्ट अगले सेशन में करना है, वही कंडीशन है नवदीप शर्मा. नवदीप शर्मा, कम ऑन. Yes, Suresh Kumar, आगे बढ़ते हैं. And mole fraction of the solvent in aqueous solution of solute is 0.8. Then the molality of the aqueous solution, that is given as yes, this is the solution. You can see XA is given 0.8 now, XB is going to be 0.2. Why it is 0.8 to 0.2? Because the sum of these two is supposed to be equal to 1. So XB is equal to M molality into molecular mass of the solvent upon 1000 plus molality into molecular mass of the solvent. Just plug it, you are going to get 13.88. ठीक है. आगे बढ़ते हैं क्लास में सुरेश. So solubility of gas in liquid, that is Henry's law. So it says solubility of gas in liquids, it is exactly explained by Henry's law. Whenever a gas is dissolving in liquid, when the pressure is increased, the solubility of the gas is increased in the liquid. That's why carbon dioxide is soluble in water at high pressures. So for that we need to say the soluble, that is given by, it all depends upon the nature of the gas and solvent. More polar gases and more polar solvents. So more is the polarity of the gas, more is going to be the solubility. As well as we can say, if the gas which is having the more intermolecular forces can be easily soluble. That's what I just want to say. Oxygen, nitrogen, carbon dioxide are much more soluble in ethyl alcohol than water at the same temperature and pressure, while H2S and NH3 are more soluble. Why? Because NH3 forms, it is going to be intermolecular hydrogen bonding. It all depends upon the polarity of the solvents, and that is explained. Effect of temperature. Gas dissolved in the solvent gives rise to solution. It is heat. It is an exothermic process. Exothermic process. Delta H is equal to negative here. As this delta H is going to be negative, as the temperature is increased, the equilibrium shift in the backward direction. As the equilibrium is shifting in the backward direction, at high temperature, solubility of the gas in the liquid is not at all favorable. Reaction comes in the backward direction. And also say effect of pressure. This is given by Henry's law. Henry says the mass of the gas that is dissolved is directly proportional to the pressure of the gas. So M is equal to K dot P. K is a constant. So if the solubility of the gas is the function of the mole fraction, I just want to say pressure of the gas is directly proportional to Henry's law constant into mole fraction of the gas. So this is the formula that is extensively used in the solving numericals. Okay, as I want to say, when the gas is at low pressure, less gas molecules are soluble. When the gas piston is down, so we are force applied, so इसमें pressure बढ़ जाएगा, so that gas molecules, more gas molecules introduced in the gas liquid, so its solubility is increased. That's what I want to say, Henry's law. Increasing the pressure increases the solubility. समझे? That's what is the effect of pressure. In this effect of pressure, solubility of gas in liquid at a particular temperature is directly proportional to the partial pressure of the gas in equilibrium with the liquid at that temperature. Okay. Suresh Kumar, let's say Dalton says the same thing. Dalton during the same period had concluded independently if the mixture of gases are simultaneously at equilibrium with the liquid at a particular temperature, तभी the solubility of any gas mixture directly proportional to इसका partial pressure का ऊपर depend करता है. I mean to say here, for any gas, it is said that pressure of the partial pressure of the gas is equal to KH is Henry's law constant dot mole fraction of the liquid. Okay, उत्तम कहाँ गए तो? नवदीप, अरे चार्ट बॉक्स में एंगेज करते रहो, क्लास का एनर्जी बढ़ने का कोशिश करो, हो जाएगा ना, पक्का हो जाएगा. Okay, you are in a winter season now, right? So most commonly used form of Henry's law may be defined as the partial pressure of a gas P is directly proportional to the mole fraction X of the gas in the same solution. So I mean to say P gas is equal to Henry's law constant and the mole fraction of the gas. Okay, this is a scenario. And the जो condition है ना, gas should not react with solvent and the pressure should be not too high, not too low. तभी ये Henry's law इस्तेमाल कर सकते हैं, limitation of Henry's law. So that is what is said, partial pressure is equal to KH mole fraction of the gas. So if you take the partial pressure and the mole fraction, it is going to be a straight line with a slope of Henry's law constant KH. ये expression जो है, it is important for NEET examination. Slope क्या होगा, ऐसे questions पूछना है. Understand? Got it? Wonderful. Now, different gases will have different KH value. जिस गैस का सॉल्युबिलिटी ज़्यादा है उस गैस का KH वैल्यू कम है. मान लो एक गैस का एक टेम्परेचर में है, अगर टेम्परेचर बढ़ते जाएगा KH वैल्यू कम हो जाएगा. सो KH इज कॉल्ड हेनरीज लॉ कांस्टेंट. मेरा को लग रहा है ये कांस्टेंट नहीं होगा, बट इट इज मेंशन्ड एज अ कांस्टेंट. ठीक है बेटा. एंड हेनरीज लॉ कांस्टेंट KH इज अ फंक्शन ऑफ द नेचर ऑफ द गैस. And greater the value of KH, lower is the solubility of the gas at the same partial pressure. According to the equation 3, so particular temperature it is a constant, right? And also values of Henry's law constant is given as the temperature is increased. You can see oxygen 293, 303 में Henry's law constant increased, solubility is decreased. Like that, these tables you are not asked to by heart, but observe how the things are happening, right? And limitations of Henry's law में आपको दे दिया. The gas should not react there and the pressure should be not too high, not too late. समझे? And also we have vapor pressure. We have vapor pressure. Uttam. So what I mean to say here, vapor pressure, the pressure exerted by the vapor molecules when this is closed at equilibrium is called as the vapor pressure. When the gas molecules, the liquid is evaporated and the liquid vapors are making a collision over heat and causes some amount of pressure at equilibrium, and at equilibrium this should take place, that is called saturated equilibrium vapor pressure, and that is depend on the kinetic energy of the gas. That is decided by, according to collision theory, is directly proportional to the temperature. So the pressure exerted by the vapor molecules or liquid when they are in equilibrium, the liquid at a given temperature is called vapor pressure of the liquid, and that decides the entire colligative properties. And vapor pressure of the liquid depends on two things, nature of liquid and temperature. So जिस liquid का intermolecular forces ज़्यादा है, उस liquid का vapor pressure कम है, so that you don't want to leave the liquid. And as the temperature increases, kinetic energy बढ़ जाता है. So the kinetic energy is directly proportional to absolute temperature. So as temperature increases, kinetic energy increases, collisions increases, and the force exerted by the gas molecules, liquid vapor molecules on the liquid increases, vapor pressure increases. So vapor pressure of a liquid at a given temperature is independent of quantity. ये बढ़िया बात है, quantity of the liquid. And the surface area, which of the following is dependent, which of the following is independent. In the NEET examination it will be given directly, you can write it, है ना. That's good, perfect. NEET examination में theory का questions बहुत बढ़िया important है. You can see in the previous, NEET examination as well, not numerical emphasis, rather less numericals, more applications, more the questions are testing you, your understanding ability. Got it, Suresh Kumar? So the way you study is completely different. The way you get the NEET examination paper is completely different. Understand? And volatile liquids and non-volatile liquids. जिस liquid evaporate करने का तैयार है, that is called volatile liquid. जो liquid do not evaporate is non-volatile. You take a petrol, it evaporates a lot. Where you take a glycerol, it do not evaporate. Understand? Clear? That's good, that's good. And also you can see diethyl ether, ethyl alcohol, benzene, water, octane. As the intermolecular force increases, vapor pressure decreases. Vapor pressure is directly proportional to the temperature. That's why हर एक liquid का vapor pressure and temperature ऐसे आता है. Okay, ऐसे आता है. So liquid A and liquid B. So intermolecular forces of liquid A is less than liquid B. So liquid B में intermolecular forces की वजह से vapor pressure कम है इससे. Are you getting or not? Clear? And आगे बढ़ते हैं. And you can see the relation between the vapor pressure and the enthalpy of vaporization is given by Van 't Hoff equation, that is log P is equal to minus delta H vap 2.303 R into 1 by T plus constant. So from there you can see this log P and versus 1 by T is going to be a straight line with a negative slope, and log P, so 1 by T is going to be the same graph is given here. Delta H vaporing, more intermolecular force will have more boiling point. So every property of the liquid is connected to vapor pressure, mind it. And also vapor pressure of liquid solutions, that is explained on the basis of Raoult law. So I mean to say liquid solution, so जिस liquid का मोल फ्रैक्शन ज़्यादा है उस लिक्विड वेपर प्रेशर ज़्यादा होगा, पार्शियल वेपर प्रेशर आई मीन टू से. सो लेट अस टेक अकॉर्डिंग टू राउल्ट लॉ, आई वांट टू से partial vapor pressure is directly proportional to the vapor mole fraction of a liquid, and it is Pa is equal to mole fraction of a liquid P naught A. What is Pa? Partial vapor pressure of the component, and P naught A is the vapor pressure in the pure state, and X is said to be mole fraction of that component. You know, A and B are the two components. You can say Pa is equal to P naught A mole fraction of A, and Pb is equal to P naught B mole fraction of P, and the total pressure of the liquid mixture is equal to Ps or Pt is equal to Pa plus Pb. I mean to say P naught A mole fraction of A plus P naught B mole fraction of B. Are you getting or not? So that is what you say P total is equal to 1 minus mole fraction of A, P naught A plus mole fraction of B, P naught B. Like that we can say. So what Raoult law says, Pa and mole fraction of A. It goes like this. Understand? And simply we can say Pb as well, and that is explained on the basis of the vapor pressure and mole fraction. For A it is given like this, and for B it is given like this, and a solution which obeys this graph is called as ideal solution, and the total pressure is going to be a connecting line between these two intercepts, that is given as a P total is equal to Pa plus Pb. Suresh Kumar, fine. And these graphs are very important. Such solutions are called ideal solution. So the solution which obey Raoult law at all temperatures and pressure is called as an ideal solution. In this ideal solutions, the graph of the solution should be observed like this. If any curves are seen, not a straight line, that is going to be non-ideal solution. Let us say ideal and non-ideals. A solution which obeys Raoult law at all concentrations is called an ideal solution. For ideal solution, enthalpy of mixing is 0, change in the volume of the mixing is 0. So जो भी condition है, मैं क्या बोलना चाहता हूँ, when intermolecular forces A and B before mixing should equal to the magnitude intermolecular forces between A and B. That is what you say this condition for ideality. If intermolecular forces are not same, it is going to be deviate from this Raoult law. That I am going to tell you here. And for example, when we mix 50 milliliters of benzene and 50 milliliters of toluene, you are going to get 100.00 milliliters of mixture. Okay, so I mean to say enthalpy of mixing is going to be 0. बच्चों समझ में आ रहा है क्या सुरेश कुमार? Very good. Hence the solution is called an ideal. Of course, a few examples for an ideal solution: benzene and toluene, anhexane and heptane, and ethyl bromide and ethyl chloride, and also chlorobenzene and bromobenzene. आप देख सकते हैं मॉलिक्यूलर नेचर का हिसाब से, मॉलिक्यूलर स्ट्रक्चर देख के आप बता सकते हैं उसमें कौन सा इंटरमॉलिक्यूलर फोर्स चलता रहता है. ओके, if hydrogen bonding is newly formed, intermolecular force is decreased, or else existing hydrogen bonding is decreased, you can say intermolecular force is decreased. That is what I mean to say. The increase in intermolecular force and decrease in intermolecular force when two liquid components are mixed, that is said to be non-ideal solution. So the non-ideal solution is the one which do not obey Raoult's law at all conditions, is called as a non-ideal solution. उसमें positive deviation होगा. Non-ideal solution showing a positive deviation when intermolecular forces like this before mixing A and B and B, and after mixing A and B में intermolecular force कम हो जाएगा. अगर intermolecular force कम हो जाने तो बात इंटरमॉलिक्यूलर फोर्स कम होना है. अगर कम होगा तो क्या होगा, वेपर प्रेशर बढ़ जाता है. वेपर प्रेशर बढ़ जाता है तो क्या होगा, देखो आपका जो लाइन ऐसे होना चाहिए, लेकिन वेपर प्रेशर बढ़ गया. यू आर एक्सपेक्टिंग ए लाइन इन दिस वे, बट यू आर गेटिंग ए लाइन इन दिस वे. यू आर एक्सपेक्टिंग ए लाइन इन दिस वे, बट यू आर गेटिंग ए लाइन इन दिस वे. आर यू गेटिंग और नॉट? But you are expecting a line in this way. So this is what you said, it's the positive deviation of a Raoult law. And this positive deviation, you can say उसमें Pa is greater than P naught A mole fraction of Pa, Pb is greater than P naught B mole fraction of B, and the total pressure is greater than 0 and greater than the sum and enthalpy of mixing is always a positive, and enthalpy of mixing is a change in the volume in the mixing is also positive. Are you getting or not? Clear? Very good. And example जो है acetone and carbon disulfide, there is a repulsion caused here. Because of the repulsion, this is going to be broken. Are you getting or not? That's the reason why vapor pressure is decreased. Got it? Clear? And an example you can say ethyl alcohol in water, carbon tetrachloride chloroform, carbon tetrachloride benzene, carbon tetrachloride toluene. Carbon tetrachloride is very important. You just all memorize this. Huh? Okay. Now let's go ahead with negative deviation from Raoult law. Non-ideal solutions, negative deviation, and I'm expecting a line like this. I'm expecting a line like this for an ideal solution, but due to intermolecular force, vapor pressure is decreased. I mean to say A and A has the vapor pressure, intermolecular forces, B and B has the intermolecular forces बच्चों. And जब A and B mix करते हैं ना, A and B वे intermolecular forces बढ़ जाएगा. So सुरेश कुमार, आपका डाउट अच्छा डाउट है. एक मॉलिक्यूलर स्ट्रक्चर का हिसाब से आप बोल सकते हैं. जहां पर इंटरमॉलिक्यूलर फोर्सेस मिक्स करने के बाद बढ़ रहा है या ना, वेपर प्रेशर कम आ सकते हैं. अगर वेपर प्रेशर कम आएगा ना, ये नेगेटिव डिविएशन होगा. हमको कैसे पता चलेगा? अच्छा बात है. यू कैन से chloroform and carbon tetrachloride, you can say carbon tetrachloride toluene, and you can also say acetone and chloroform. Acetone and chloroform. Acetone and chloroform. Acetone में क्या होगा? CH3 CH3 डबल बॉन्ड O. क्लोरोफॉर्म में क्या होगा? Because of the strong electron withdrawing group, इसका बिना इसका हाइड्रोजन बॉन्ड नहीं था, उसमें भी नहीं था. ये दोनों मिक्स करने के बाद तो नया नया हाइड्रोजन बॉन्ड बन चुका. अगर नया नया बॉन्ड्स बनने के बाद इंटरमॉलिक्यूलर फोर्स बढ़ जाएगा, वेपर प्रेशर कम आएगा. सुरेश कुमार, आपका डाउट क्लियर है? जहाँ पर वेपर प्रेशर जो कम है, नेगेटिव डिविएशन. यहाँ पर वेपर प्रेशर ज़्यादा है, पॉजिटिव डिविएशन बेटा. सुरेश कुमार, होप यू अंडरस्टैंड. यू नीड नॉट हैव टू मेमोराइज एनीथिंग. जस्ट चेक इट. नया बॉन्ड बन रहे हैं, पुराना बॉन्ड तोड़ना है. अगर मॉलिक्यूलर स्ट्रक्चर बराबर दिखता है नो, आपका से आइडियल सॉल्यूशन है. वंडरफुल. अरे उत्तम, कहाँ गए तो? अरे आते जाते. Okay, let's talk about the vapor pressures of this. PA is less than P naught A mole fraction of A. PB is less than P naught B mole fraction of P. And the sum is going to be enthalpy of mixing is negative deviation होगा. Enthalpy of mixing is negative, that is volume of the mixing is negative, is an example. Thanks. अरे thanks कैसे बोल सकते हैं? Chloroform and benzene. Chloroform diethyl ether, acetone and aniline. What is aniline? Aminobenzene is called aniline. HCl and water and HNO3 in water, acetic acid and pyridine. So many examples are there we can learn. And you can say azeotropic mixture. They are called as constant boiling mixture. NEET में ये काफ़ी important है. नीट में काफ़ी इम्पॉर्टेंट है. एंड आता है द azeotropic mixtures are non-ideal solutions. They have the same composition in liquid phase and vapor phase, so that they are going to boil together. I mean to say the mole fraction of these two components is the same both in liquid phase as well as in the vapor phase. Such liquids are called as a constant boiling mixtures or called azeotropic mixtures. And Satyavir Singh, hi. So I want to say these are two types of azeotropic, minimum boiling azeotrope and maximum boiling azeotrope. ये कैसे पता चलेगा ये मिनिमम बॉइलिंग एजियोट्रोप है, मैक्सिमम बॉइलिंग एजियोट्रोप है? जो लिक्विड मिक्सचर नेगेटिव deviation of Raoult law is a positive boiling azeotrope, and that liquid is showing a negative deviation from Raoult law is a positive deviation, positive boiling mixture, azeotropic mixture, and the positive deviation from Raoult law is called negative boiling azeotrope. Hope you understand. And the same minimum boiling azeotrope. Ethanol and water mixture shows a large positive deviation from Raoult law and can show minimum boiling azeotropic mixture at certain composition. हर composition में नहीं देखता इसे. And this appears this composition like this: acid, ethanol and water in this proportion, and this proportion is going to form azeotropic. So 95.6% of ethanol in water is a negative minimum boiling azeotrope. Okay, शिवम भारद्वाज, डिप्रेशन फील होता है? अरे बेटा डिप्रेशन बिल्कुल नहीं चाहिए. यू नो वन थिंग बेटा, पीपल हु आर राइटिंग नीट एग्जामिनेशन असली तरीका प्रिपेयर करने वाले कम से कम 20% का अंदर आता है, एंड रिमाइनिंग 80% है ना, दे आर सिंपली एप्लीकेशन देते हैं, एग्जाम देते हैं, कंपटीशन नहीं देते. कंपटीशन देने वाले सिर्फ 20% में अंदर आते हैं बेटा. हाँ डॉक्टर्स, आप मोटिवेट करना है शिवम, सुरेश, आप कितना बार मोटिवेट किया सुरेश को? कोई बात नहीं है भरद्वाज, कोई बात नहीं. You only have to motivate others. So don't feel tension for the examination. Okay, आपका जैसे किसान है ना, साल भर मेहनत करते हैं. Okay, in the rain, in the sunlight, okay, in the cold, he works a lot to raise the farm, है ना. जब हार्वेस्ट करने का फल मिलेगा ना, जस्ट हार्वेस्ट करने का वक्त में ये सेलिब्रेट करते हैं. आप लोग इतना मेहनत कर रहे हैं, एग्जामिनेशन करने के वक्त में हार्वेस्टिंग का जैसा ये सेलिब्रेशन है. अरे रिजल्ट इज अ बाई प्रोडक्ट, आप जो कर रहे हैं ना सही है. ओके, इफ यू थिंक हियर एंड देयर ना, अननेसेसरी टेंशन विल कम. डोंट थिंक एनीथिंग. सिंग, stick on to the exam, stick on to the subject, stick on to your life and your just your commitment. That's it. अरे आगे एग्जाम में नहीं मिलेंगे तो क्या होगा? If that comes into the mind ना, it create a lot of pressure. You please don't fall like that. Okay, so you always think on that subject way. If you have any backlogs or anything need to cover, you cover in a shortcut way and follow us. Write something in the comment box. I am going to read it, and if you have a topic want to know for you, Bharadwaj, I can schedule a class on YouTube, live class for you, right? And I can do for the entire student community. इन लोगों को भी फायदा होना चाहिए, है ना बेटा? राइट. शिवम भारद्वाज, डॉक्टर बनने की कोशिश करो. सही है ना? Okay, dear children, we are at the minimum boiling azeotrope, maximum boiling azeotrope. Nitric acid and water mixture shows large negative deviation from Raoult law and can form maximum boiling azeotrope. उसमें the boiling point curve like this. Okay, so I mean to say here 68% by nitric acid in the water is going to be a maximum boiling azeotrope. So today we discussed up to vapor, pressure and Raoult law and concentration terms and types of solutions, everything. और एक सेशन शेड्यूल करने को मैं कोशिश कर लेता हूँ. ये सेशन में आपका टोटल सारा के सारा कॉलिगेटिव प्रॉपर्टीज एंड वन एंड हाफ फैक्टर्स आपको देना तैयार हूँ. ग्रेट. ओके, सो वी आर डन फॉर द डे. होप यू लाइक दिस सेशन माय डियर स्टूडेंट्स. कीप motivated because the examination आगे आगे आना है. So don't lose your confidence and stay with us. We are going to take you, we are going to drive you in a appropriate way to reach the medical college. Believe in us, and you follow our lectures and share with your friends and subscribe to Infinity Learn NEET channel. And thank you very much for your students for this time. I am delighted to enjoy the class with you. Bye bye. Thank you, thank you. और एक बार thank you बोलो. Bye. फिर मिलेंगे. Bye. See you. Signing off, Suresh.